All right, so we're gonna go over engine troubleshooting and inspection. I think it's a little more over inspection than troubleshooting, but we have more curriculum to cover than just what you guys are gonna be talking about. So, let's start off with Justin. What question did you have? You don't have to say that. You don't have to say that. That's very nice.
Alright, I got a modern maintenance theory is called. And my answer was modern maintenance theory, sometimes referred to as proactive maintenance, is a shift from traditional baby boomer reactive approach to more of a millennial Gen Z, more forward-thinking strategies. We focus more on preventing equipment failures and optimizing assets before performance issues occur. Back in the old days, they used to say, fix it when you break it, fix it when it breaks, or if it ain't broken, don't fix it. Back then, they did not have the technology for the data-driven decisions. Now using sensors and collecting data, modern maintenance relies on real-time historical decisions and predict when maintenance is truly needed. The end.
Okay, yeah, that's a good answer. Does everybody understand, what the advantages of that over just doing constant maintenance of just throwing parts of something, or does everybody get that idea? So what's the advantages?
I would say more longevity of parts, because it could be a minor repair of that individual part, so replacing the whole thing. It saves money as well.
Sure. Is there something else that comes into factor, with that kind of ideology of maintenance? Is there another word or something that they tend to utilize? How do they get all of that information, that data? How is it derived? Trend, right? So you guys, because this thing's recording, you probably have to speak up, but yes, trending, right? So all that information was derived from trending, right? They pretty much crunched all that data and numbers to figure out when something's gonna fail. And so that allows you to replace that part before failure, right? So. Okay, good answer. Hunter? And yeah, like you said, please speak up a little bit, just. What was your question?
Reliability, center maintenance, RCM, and I just, a project that ensures maintenance tasks are performed in an efficient, cost-effective, reliable, and safe manner.
So that falls right under the same thing we were just kind of talking about. So. Did anybody read like some of the first jet engines, how much maintenance was required in the beginning compared to where we are now? So if you read some of that introductory information, you'll find out that some of the first jet engines weren't very cost effective. They literally required maintenance every several hours, you know what I'm saying? But with this trend monitoring and RCM and all that, some of these commercial aircraft stay on the airplane for years, right? And they're just being serviced. And they can get that kind of longevity out of engines now. And it's due to that concept, right? And the advancement of materials and those kind of things also. Phyllis, what do you have?
Explain the water incident effects. Well, what I got is pretty much less maintenance is beneficial in two primary ways. First, maintenance itself is often the biggest cause of failures, known as maintenance-induced failures. They cause a lot of additional maintenance due to human error and the tendency of machines to fail more when they have been disturbed. Today, this is known as the Waddington effect.
Did everybody understand that? The effect, the water So, going back to what we were talking about, engines that required a lot of maintenance, right? Because, what they're saying is, what drives, what he was saying, what drives more maintenance?
Human error.
Human error, by performing more maintenance, right? More chance of making an error, right? So the more like you do constant maintenance on something, human error goes into factor, right? So everybody understands that idea?
Yep.
Okay, Dennis?
When an engine is removed from an aircraft, what are the follow-on inspections? I put visual inspections and borescope inspections. Or inspections.
I mean, okay, so put yourself in the position that you're just a ramp person, and your job is to remove that engine, right? And so say it had some kind of problem, right? And they want you to pull it and send it back to the shop. So, do you think you'd still perform those inspections?
Yeah.
You think you're still gonna perform a borescope inspection and do a visual inspection on it? Well, so if you're the ramp guy, right, you're not an in shop, you're not back shop. So think about that. We've talked about this during engine removal and installation. It's always a big hit of mine. I always really go over this with you, like, because what's the follow-on inspection after the engine removal?
Engine bay.
Engine bay, right? Pylons, mountings, things like that, right? Anything associated to that aircraft that engine is around, inside of, held by, right? All the equipment that gets hooked up to it. So, all that stuff is your responsibility, right? If that's your assigned job on the ramp. And the reason I say the engine isn't your priority because they wanna get that engine to the shop for repair, right? So a lot of times they won't have you inspect that engine after you remove it. Because when it goes to the shop, it's gonna get those inspections, right? So your job is gonna be getting a new engine, get that other engine out of there as fast as possible, get a new engine and get it in place, right? And then do all the tests and everything, right? That's usually what the ramp, engine guys do. So, now could they be tasked to do borescopes?
Yeah.
Yeah, why? Why would they might have to put a borescope in an engine?
Check for cracks or verify problems with indicators.
Right, so borescopes can use for inspection, right? Mostly inspection purposes, right? So, what about internal type problems? Fog, yeah, you might have fog on the blades, the first aid blades, so you need to look further downstream, right? But what else? What other kind of troubleshooting would you use for a borescope? So FOD is not troubleshooting. So what would you use a borescope to troubleshoot?
Oil leak.
Check to see if you're still
Oil consumption?
within limits. with
What
that
else
one
does the engine
inspection.
use besides oil?
Air.
Fuel. Yeah, I mean, air, you can still sometimes see air leaks. You might because of the way, stuff is blown out of things. Sometimes there's exhaust, there's oil, there's things that can show air leaks. A lot of times air leaks will probably be hard to find, you know what I'm saying? But fuel and oil, for sure. I mean, the borescope's used for troubleshooting, right, for those types of things, right? It could be used for even, if you have an overheat condition, an engine's over-temping, you may go into the hot section and find erosion that's out of limits, right? You may find things that are causing that engine to overheat. So, all right, Ramondo?
He said, what does the troubleshooting process consist of? He said, identify the problem, understanding the cause, and finding the solution.
All right. can you say, pull your thing down? Let me, can we, all right, slow down a little bit.
It says, what does the troubleshooting process consist of?
The troubleshooting process.
Consist of.
Oh, consist of. Okay. It's not his fault. No, it's not his fault.
It says, well, what I found is identifying the problem, understanding the cause, and finding the solution.
So there is a process to troubleshooting, right? And what you have for answers?
Identify the problem, understand the cause, and finding the solution.
Okay. So when you're gonna go troubleshoot something, what is gonna help you? I mean, you have to have certain things, right, to troubleshoot. So what are some of those things that are gonna help you troubleshoot something?
Service manual.
Yeah, tech manual, right, tech data, you're gonna need tech data first thing and foremost, right? What else do you need when you're gonna go troubleshoot?
Probably need a specific equipment,
A specific what?
specific tools and equipment, or.
Tools and equipment, right? Maybe you need a borescope. Maybe you need, a jet engine cal analyzer. Maybe you need certain equipment, right? That's correct too. What about yourself?
Safety glasses.
Yeah, you obviously need PPE, and that's true, but a little deeper than that. Like, as an A&P mechanic, and they send you out to troubleshoot, what do you think you're gonna need?
References.
Well, yes, you need to know
Have a tech data.
tech data, but what if you don't understand the tech data?
Question?
You can read tech data and not have a clue what you're talking about, right, or what you're reading. So what do you need to understand that tech data? What do you need to know? What helps you understand tech data?
Other people?
A teacher.
Someone else? And why would you use somebody else?
More knowledgeable.
What is it?
Knowledgeable.
Knowledge, right? So if you don't have knowledge and you go out to troubleshoot something, you're not gonna get very far, right? Yes, you'd probably take somebody with you, that has the knowledge, right? So you need an understanding of that system, right? No matter what, if it's the aircraft, avionics, hydraulics, you need to know that system, right? If you don't know it, and you're gonna go troubleshoot, it's gonna be a long day for you. Right? It really is fun. So. Alright. Benjamin, what do you have?
How are hot section inspections determined or required? Hot section inspections are normally required on a time or cycle basis, but anytime the EGT becomes excessive, a hot section inspection should be performed.
Okay, so what was the main point out of that?
On a time or cycle basis.
Time or cycle, right? Yeah. Flight time or engine cycle time. Does anybody know how cycle times are figured out? So flight time's pretty easy, right? The plane flies 1 hour, it clocked 1 hour, right? What's that? Oh, on cycle time?
Cycle times
So cycle, and I don't know if you've read anything on that yet, but cycle has to do with the thermal characteristics from going to idle to mill and back and forth on the throttle. So what do you think happens every time you go from idle to mill and part power and then back to mill? What's going on inside that engine?
You're reducing its lifespan because it's constant.
Yeah, what causes a reduction in lifespan?
Well, contracting.
Yep, expansion and contraction, right? Every time you go through a thermal cycle with that engine, it is reducing the life, right? If it's getting really hot, it's cooling down, and you put it back to heat, it's expanding. So if you think about it, what is the metal doing? It's contracting and expanding, so it's weakening the metal every time it does it, right? It It also will cut into other materials it's designed to cut into. And sometimes engines, as they get hotter, because they're gonna run hotter over time, because they're gonna adjust fuel to trim, and they're gonna expand even more, and they're gonna keep cutting into this abradable material, so you don't lose that energy, right? And after time, that material gets worn out of limits. So it's just, that's another way they calculate how many cycles they can get out of an engine. So it's time, it's hours and cycles, right? Levi?
Okay, 4 inspection tools. 2 of them are actual tools used to inspect. The other 2 are information tools. The 2 inspection tools I found are rigid tube borescope and flexible tube fiber optic inspection scope. The tools for information are engine monitoring unit and engine indicating and crew awareness system.
So did that say how many tools to list, or
It
did
said name 4.
Name 4, okay, so what
2
were
inspection, 2 information.
information, and what else?
Inspection.
Inspection. Okay, so they want you to break it down a little more than that.
Like an explanation of them.
So what, if you were, like we talked about, tools you would need to go inspect or troubleshoot, right? Was yours inspection or troubleshoot?
Inspection.
Inspection. Okay, let's break it down to a little more. Whenever you're inspecting something, and this is just say, you're gonna inspect the engine prior to teardown in the shop, right? So, what are the things we're gonna need? Okay, you said information, right? We definitely need information, right? You need to know what you're looking for, what to inspect, what the limits are, right? You're gonna need that. So, you have technical data or engine maintenance manual, right? So, what else? If we break it down to just like what you need, if you're gonna, I send you out to go look at that engine and tell me what's wrong with it, what are you gonna grab out of your toolbox?
Flashlight. Mirror.
Yep, flashlight, right, good flashlight, you need, I've reiterated many times that, if you are not looking at something with a flashlight, you're not doing a very good inspection, alright, you're gonna miss stuff. Engines, you're underneath the engines, it's dark, you're looking at tailpipes, you're looking at intakes, guess what, the lighting stinks, so always have a good flashlight with you, right? What are some other things that you might need to inspect the engine? You go out to the shop, I tell you to give me a full inspection on that engine. What else?
Mirror.
Borescope, yes, mirror. So here's an odd one, right? You can get information from other shops that you work with. So if you wanted to get troubleshooting information from another shop, other than your engine shop, where would you might go to say, hey, give me a rip on this. Give me a rip on this information, on this engine. What is it? I couldn't hear it. Well, so what other systems are there, so, that get monitored by people other than Jet you may download all the information and send it to the engine manufacturer, but locally, there's an inspection on something in the engine constantly, usually every time it lands. I don't know about civilian, on the civilian side, but there is a system in the engine that usually gets monitored, and it's usually not by the jet engine mechanic. Does anybody know?
You.
Well, what else does the engine use besides fuel?
Oil.
Oil, right? Does that oil ever get monitored?
Yeah.
Or do you think it just stays in there like forever until time oil change? It actually gets, it gets monitored, right? Do you think they keep a history of that?
Yep.
So what are they looking at when they're trending oil? Like what is?
How much
and-
more?
Like, so yes, so normally who does it is NDI, non-destructive inspection, they're in charge of, they do all the MagnaFlux, they do, the eddy current, but they usually also do the oil analysis, right? So, if you had an engine that was, like, had metal chips and stuff in it on the chip detector, why would you wanna go to the joke lab to maybe ask them for information?
Because it could have,
Well, can they, when they burn oil, can they find out what kind of metals being burned? Yeah. That's, spectroanalysis, right?
by the,
They literally can tell if it's aluminum, iron, magnesium, they can tell what's being burned, right? So that might give me a clue, right, to look at where the metal's coming from. That's probably gonna give me a clue, right? So trend analysis, that's the other tool that you would probably need if you're going to go inspect an engine or troubleshoot, right? Trend analysis, borescope, good light, and tech data, right, a manual, those three things, right? Okay, Jameson, what do you have?
My question was, how would you verify a suspected crack in an engine part? The two ways, well, one way you're gonna do it is through an inspection, but if you don't wanna tear down the whole engine and you have access to a borescope or fiber optic, then you can just borescope it, look in for it.
What if, you borescope it, it looks like a crack, but you're still not sure, like, the borescope can't really define a crack, it can look like a crack, there's a lot of stuff that looks like cracks. Scratches, gouges, even water lines, you get jagged water lines on blades and things like that, and they look like cracks. But that's internal, but we're talking more external, like first stage blades or a tube or something. So what would you do to verify you have a crack? What would you?
Well, besides looking at it with a flashlight, if I still can't tell, you can always just take it to NDI, mag particle, or.
Mag particle,
Like,
right?
yeah.
Mag particle, that's really what they were looking for. Anything that's easy access, they're gonna usually mag particle it, right, because it's right there, you can do it, right? You're taught to do that, you actually can do it. So, like, I don't know if you guys will ever be taught eddy current and all that, but once again, when we had that problem in the military, we just called NDI and we said, hey, this is an eddy current inspection, can you come to the shop and do it? And they'll just show up, bring their equipment, and do it, okay? Chance, what do you have?
So, I read this question, I wanted to make sure this is what was being asked, but, what are 4 different methods of non-destructive inspection? That I originally put down, like, there's visual, there's magnetic particle, there's dye penetrant, and there's eddy current. I went on, I did one just 4, and what I found, but then I was like, same
So
inspection.
you had dye penetrator, right?
Yes.
What else did you have?
Magnetic particle.
Magnetic particle.
And I have, eddy current, ultrasonic, and visual. I went and did pass 4, and then I was looking through a little bit, I'm not gonna lie, and I was like, is he wanting just that, like this, just felt like a little too easy, and I was like.
No, those are good answers.
Okay.
Everybody understands how each one of those inspections are done.
Yes.
Right? Dye penetrant, magnetic particle,
That worked.
eddy current. They really come a long way, right? You know, in the days of finding defects in metal, right? What if you had something giant like a wing, and you wanna check like the spars inside? Would you be able to do that without taking all the skin off of it? What can you do, what can they do nowadays to inspect stuff like that, like a wing? I'll let Chance, cause it was his, do you know what? you guys
It's like a wing.
Do what?
Like if, like they're expecting inside wing, I'd say, I mean, could it possibly be put into like different sections? Like Jason?
Well, so what would you use? Like, so you can't use any of those, right? You can't use dye penetrant magnet.
Yeah.
You can't use any current.
Just maybe,
Because you're not gonna take all the rivets off a skin, right? So how would you see in there without doing any of those types of inspections? Without visually looking?
ultrasonic, probably.
Is there any other thing? Like what if,
X-ray?
X-ray, right?
X-ray glasses.
They are using X-ray a lot these days. They're using X-ray, and it actually, I've seen them do it at our base, and, the clarity of the pictures that they get with X-ray is pretty impressive. They literally can find cracks, you know, in wings, internally. So, it's pretty cool stuff. All right. Natalie?
My card said name 4 useful tools or requirements for troubleshooting. So depending what it was, I put multimeter, borescope, things like screwdrivers, ratchets, sockets, access panels, applicable manuals, schematics, troubleshooting charts, things like that.
For troubleshooting. I think some of that stuff's gonna still revert back to troubleshooting. You need a basic knowledge, right? You need knowledge, of the system and how everything works, right? You said multimeter, right? Good understanding of the system. Alright, so obviously troubleshooting guy's gonna be in the maintenance panel, right? When you can't figure out from the troubleshooting tree, say it's an electrical problem, what are you gonna resort to? Like if you still, almost all troubleshooting trees are gonna be like, if you can't find a problem after this point, resort to what? Yeah, you can do that too. But you guys just did it in your troubleshooting. What you guys had to resort to looking at something? Do you remember what it was? Diagrams, schematics, right? Schematics, right? So, yeah, schematics are gonna be part of your troubleshooting, okay? So, Sam? what do you got?
Yeah. I said, modern horoscopes have the ability to perform these operations. I think now they're called videoscopes or, industrial endoscope. Basically the purpose is to view inside, with aviation mainly, it's inside engines, turbine engines, without disassembling it. They can provide magnification, they can record, they can get into tighter spots. Typically be inspecting like compressor blades, burner cans. The modern ones can now, I guess, help identify defects, they can measure them as well. Identify types of debris, imperfections, identify thought damage. And then some of the new ones, they have like they have multiple cameras that, lighting.
Alright, is there an advantage, like, for one that can record. Like if you could record it, the damage, maybe it's something weird you've never seen in your maintenance career. So why would you wanna record that?
So other people can get their judgment on it.
Right, so maybe you need to send it to the manufacturer, right? Maybe it's not covered in your tech manual, maybe it's something new. And that does happen sometimes. You'll see stuff that, that's not even covered in the book. So you can't just call it good because you don't know if it's good or bad, right? It's like, you've never seen it, it's not in the book, it must be good, I'm gonna let it go. No, you need to record it, you need to show it to your supervision. Normally, they're gonna send it off to the manufacturer and say, hey, can we keep using this? Can we keep flying it, right? That has happened in the 229 jet engine world. I've seen stuff that wasn't even in the book. And then the engineers have to address it, right? But that's their job, because they get to take the hit. If they let it go, then it's a problem, right? That's one of the other things, I don't know if it's talked to a lot here, which I know it was covered a few times, but, you know, as mechanics, whether it's the aircraft or the engine, you don't get to repair something if you don't have a process to do it, right? So, and even though Joe Blow comes up and says, hey man, I've done this a million times, it's fine, don't worry about it, right? And you go, show me in the book, where's that at? And he goes, it ain't in there, but we all do, right? Well, I wouldn't put my name on something like that, right? Because, believe me, it's not that big a deal. You go to your supervisor and you say, I can't repair this by the book, right? Do you wanna replace it? What do you wanna do? And then it's on them, right? It's not on you anymore. You don't accept that responsibility. They send that information off to an engineer, and an engineer maybe gives you a waiver, right? Maybe it's just for 10 flight hours or something, but they get to make that decision. So always remember that. That if you don't have the data to fix or repair something, make sure that you up-channel it to somebody else, okay? Because it could be minor, like changing a bolt out to another bolt, right? I mean, that's not authorized, that's not the correct bolt, right? But it doesn't mean that that bolt was designed at the same strength as any other bolt, right? So it all comes down to even the little things. I always say maintenance 101 is the beginning of your process of being maintainers. And if you don't do maintenance 101, you're probably not gonna be respected as a mechanic. Okay, so we pretty much covered, some information there. We'll go over some more tomorrow. I know you guys are about to get out of here. Did anybody have any questions? I know you guys are, but at least you had to interject, right? You had to like describe something. You had to teach your fellow students. What's up?
So you're talking about like, no, they're not getting an answer in the book for something that's broke. Like, let's say that, you know, I'm just working on something and I see a bolt that I take something off, I see the bolt is just sheared. Like, I can just replace that, right? That I don't have to like talk to anyone else about that, right?
Yeah, I mean, it's
Same bolt.
yeah, a lot of times, you can repair or replace something, but if you notice it like maybe reoccurring, you know what I'm saying? Like, if it starts to look like it's trending, that's a trend, right? Something is creating a stressor for that bolt and then causing it to break. Well, then you might wanna say, I don't know why this is happening, right? Because, you know, we had problems with test cell. We were having excessive fuel control leaks, right? Well, we had just had a new fuel pump put on the test cell, right? So we didn't like know if maybe it was exceeding fuel pressures, right? So we had to do some troubleshooting because it wasn't normal, right? So you still think outside the box, right? If it's just one bolt out of 500 volts or whatever you want to say, you probably just maybe someone fractured the bolt installed, right? So But if you see something that doesn't look like norm, then you should bring it up to someone, right? Once you start getting into, you know, the daily grind of being a mechanic, you're gonna see what's normal and what's not. It comes with that knowledge, but it never hurts to ask. You know, it's never gonna hurt to ask, like, hey, could this be a problem, you know? You could ask somebody. Maybe they've seen it before, maybe they've, you know, seen it trending, so it's good to ask. Any other questions?